Hi, Mr. Corsi here. This video has the complete detailed solutions to all the questions in the AQA Higher GCSE Maths Paper 2 exam from 2024. Now there's a lot of questions, but to find the particular question you might be interested in, you just need to scroll along the timeline below the video. So I hope you find these solutions are useful in your journey towards success in your GCSE exam. So here's question 1. And this diagram shows a circle. It's got a centre O and there's 3 straight lines with a couple of shaded areas. And we have to use one word to describe each of these shaded areas. And we've got a selection of words that we can choose from: arc, chord, sector, segment, tangent. Now, look inside your memory. Somewhere in there you should have these. If you don't have these, the meanings of these words, then learn them. Let's look through this. Radius, centre out to the edge of the circle, the circumference of the circle. From the centre out to the circumference, that's your radius. Diameter goes right through the centre from one point on the circumference to the diametrically opposite point on the circle. Circumference all the way around the circle. A chord, 2 points on the circumference joined up. That's what the diameter is. So the diameter is a special chord. Chords in general don't need to pass through the centre. 2 points on the circumference, join them up. That's a chord. Now the arc is part of the circumference of a circle. Tangent's a line which just touches the circle at one point. It's like a wheel rolling on a road surface. It just touches at one point. That's a tangent to a circle. Here's a chord. The area between that chord and this arc of the circle is called a segment. There's 2 radii and an arc. The area in between that is called a sector. Now these two are easily confused, a segment and a sector. Segment, chord and arc, sector, 2 radii and an arc. So let's look at the picture we've got. That sector is there. That segment is there. So A, region A, is a segment because it's contained by a chord and an arc. Region B is a sector because it's contained by 2 radii and an arc. So here's question 2. And we're told that the mass of an iceberg is 2,200,000 kilograms. And we're told that this is a 12% reduction from the original mass. Iceberg melts over time. They're wanting us to work out the original mass of that iceberg. So a 12% reduction, let's say that the original mass, that'll be 100% of the iceberg. And it's been reduced by 12%. So what percentage is now left? Well, we would take 12 from 100 and we'll get 88. So 88% is left. So there's what we've got to go with. 88% of the original is 2,200,000 kilograms. So how do we get 100% if we've sitting looking at 88%. Well, one of the ways is to figure out how to get 1%. And if we know 88%, 1% will be dividing by 88. So we would take this figure and divide it by 88. And we've got calculators, we'll do that in a wee minute. Now that's only 1% of the original iceberg. Well, at least that's progress, because now how do we get to 100% if we know what 1% is? Well, we would multiply by 100. Take this number, whatever it is, and multiply it by 100. And we've now got the wee recipe that will give us our answer. So we now need to bring on the calculator. And here we have it. So let's do that calculation. So that's 2,200,000. We divide that by 88 and then multiply by 100. And there we go. So the answer to that part of it is 2,500,000 kilograms. However, the question says give your answer in standard form. So on my calculator I have a button ENG, and if I press that, my calculator now goes into a different mode where it can take this number. So I'll take that answer that I just got and then press equals. It changes that number to standard form. That's a piece of magic that my calculator does. Your calculator also can do that. So find out how your calculator changes numbers to standard form. There is another way of doing it. If we take a number like this, understanding how this works, the decimal point's at the end there. This is the millionth column. But we're wanting to get a number between 1 and 10. That's important by moving this point along the number. And to do that, we would have to move it between the 2 and the 5. And basically what this times 10 to the power does, this number, 6, tells you how many places to move that decimal point back, 1, 2, 3, 4, 5, to get to where it was. So that's really 10 to the power 6, 6 tens multiplied together, that gives you 1,000,000. If you're multiplying 2.5 by 1,000,000, you get 2,500,000. But this is now called standard form. So, what is standard form? A number between 1 and 10, and the instructions for getting that point back to where it was at the end. 6 places to the right. There it is. Move it 6 places to the right. But it's much easier if you know how your calculator can turn a number into standard form. And then there'll be no doubt that you've done the thing correctly. Oh, here we've got a chef with a tub of blueberries. What's she going to do with these? She's going to make desserts. She's going to use all the blueberries in the tub, and she's going to put the same number of blueberries in each dessert. Now, we're given this formula where the number of desserts is big D, capital D, and this is the number of blueberries in each dessert. And that, remember, is the same number in each desert. And the question asks us, first of all, what on earth does that stand for? Well, let's do a simple example. Suppose we've got 6 desserts that she's making up. Remember, she's got this big tub of blueberries. And suppose she wants to put 2 blueberries in each dessert. Now, here's a bowl. Here's another bowl. So these are the 6 desserts that she's making up. So we've got a picture of 6 bowls. And she plops 2 blueberries in each bowl. Now, we know that you'll get 6 by dividing 12 by 2. So what on earth does that 12 stand for? Well, there's 2, 4, 6, 8, 10, 12. Total number of blueberries in the tub. Number of blueberries in the tub. So in this simple case, she started out with 12 blueberries in the tub. And she wants to put 2 blueberries in each dessert, and she uses this formula to find out how many desserts she makes. 2 into 12, oh, well, that's 6 desserts I'll make. So what does the constant k represent? It's the number of blueberries in the tub. Well, let's have a look at part B. We've asked to complete this table. Now, in the first column, we can see that we're given a value of B and the corresponding value of D. So let's write that down. B is 2, D is 120. And well, let's put these values into this formula. So it's 120 equals K divided by 2. Now, what can we do with that? Well, it's like an equation. Let's get rid of this divide by 2. We'd do the opposite, multiplying by 2. And of course, equations are balanced. We'd have to do the same to the left-hand side. So, to get the value of k, we multiply both sides by 2. We'll get 240 on the left. This divide by 2 cancels out with this times 2, and we're left with k. In other words, the number of blueberries in the tub we now know is 240. So in that formula, we do know a bit more about it. We know that we're starting with a tub with 240 blueberries in it. Well, let's see what part the second column is about. Well, in this case, we know B is equal to 6. And let's put B equals 6 in this, and we should be able to work out what D is equal to. 240 divided by 6. And you do have calculators, so the answer to that would be 40. In other words, we've got 240 blueberries in the tub. Each dessert has 6 blueberries in it. That means we can have 40 desserts. The last one, we've to find B. We know that D is 30. So again, let's use this formula. But this time we know D is 30. So what does that mean? Well, it means that 30 is 240 divided by something. Well, we're in an equation again. Let's get rid of this divide by B by multiplying by B. Do that to both sides. Keep the thing balanced. 30 times B that goes, divide by b times b, they disappear, you're left with 240. Let's get rid of this divide by multiplying by 30. Opposite would be divide by 30. So if I divide both sides of this equation by 30, we should end up with b on its own, 240 divided by 30, and again your calculator will help you here. You'll get 8. And what that means, if we've got a tub of 240 blueberries, 8 blueberries in each dessert, and you'll get 30 desserts. Now the one way you can check all this works, number of desserts, number of blueberries in each dessert, if you multiply these, you should get your 240, the number in the tub, and 2 times 120, certainly 240. If we've got 40 desserts, each having 6 blueberries in it, 40 lots of 6, that's 240. If we have 30 desserts, each with 8 blueberries, 30 times 8, 240 blueberries altogether. So that looks okay. So here's question 4. In part A, we're shown a spinner with 6 sections. We're told that these sections contain the numbers 5, 6, 7 or 8. Each number appears at least once, and the probability of an even number is the same as the probability of a 7 being spun. So, at least 1 5, at least 1 6, at least 1 7, at least 1 8, they appear once at least. And the probability of an even number is the same as the probability of a 7. Now at present, that's not true. The probability of an even number will be 2 out of 6 at least. The probability of a 7 appearing is just 1 out of 6. So we need at least 1 7. Now the probability of getting a 7 is 2 out of 6, 2 sixths, and the probability of getting an even number is 2 out of 6, the 6 and the 8. If we put another 7 in there, the probability of 7 would be 3 6, and even would be still 2 6, so that's no good. We certainly can't put another even number in there, otherwise we'd get the probability of an even number being 3 6, whereas the probability of a 7 would be only 2 6. And remember, we only have the numbers 5, 6, 7 and 8 to choose from. So we said we can't have a 7 and we can't have another even number. Well, that doesn't leave us much choice. That has to be a 5. And let's just check it. The probability of an even number, well, that's only the 6 and the 8, so that's 2 chances out of 6, 2 sixths. And the probability of a 7, 2 chances out of the 6 when it's spun. So that's the completion of the spinner. There's 2 5s, 1 6, 2 7s and 1 8. Doesn't matter the order they're in, so long as that's the numbers that are on the spinner. Work out probability of 5. Well, the probability of a 5 being spun is 2 sixths, which can be written as 1/3 when we cancel 2 from that fraction. So 1 out of 3, 1/3 is the probability of a 5. So let's have a look now at the second part of that question. There's a different spinner. It's 10 sections and they're each labelled A, B, C or D. the probability of an A appearing is once out of 10, 0.1, one chance out of 10. The probability of a B appearing is 5 chances out of 10, 5 tenths, 0.5. Probability of a C appearing is 2 chances out of 10, 0.2, 2 tenths. And finally, the probability of a D, 3 chances out of 10. Now, that's interesting because if we look at the sum of all these, we'll get 1 plus 5 plus 2 plus 3, that's 11. The total of these is 11 chances out of 10. Now that does not make sense. We should have a total of 10 out of 10. If we look back at this spinner, you've got the probability of 2 5s, of a 5 being 2 6, of a 6, 1 6, of a 7, 2 6, and an 8, 1 6. And if you add these up, 2 plus 1 plus 2 plus 1, you'll get 6 chances out of 6, which is what you should get. This should be 10 out of 10. Total should be 10 out of 10. So give one reason why there must be a mistake in the table. The total is 11 tenths. The total should be 10 tenths. So that's the reason why there's a mistake. So here we have question 5. And in part A, we're given a sketch of the graph y equals negative 2x plus 6. So that's basically a formula that allows you to work out the y-coordinate if we know the x-coordinate for any point along that line. So in particular, if we have x being 0, which is what's going on for point C, then we can work out the y-coordinate using this formula. Negative 2 times 0 plus 6. Well, negative 2 times 0 is 0. 0 plus 6 is just 6. So 0, 6 will be the coordinates of the point C. That's up here. 0, 6. Let's do point D. This time we have to work out the x-coordinate, knowing that the y-coordinate is 0. So this time y equals 0. So let's put y equals 0 there, and whatever the x-coordinate is, we know when we multiply it by negative 2 and add 6, we'll get 0. Here's an equation to solve. So let's add 2x to both sides of this equation. Now the reason I'm doing that, you'll see in a wee minute, but when we add 2x to 0, we get 2x. When I add 2x to negative 2x, that vanishes, and we're just left with this 6. So twice the number x is 6. X must be just 3. We'll divide both sides of this equation by 2. You get x equals 3. So D is the point 3, 0. There it is, 3 along, you don't go up. There's the point D. So that's the two sets of coordinates for part A. Let's have a look at part B. And in part B, we're given a sketch of a quadratic graph, and we have to complete the following statements. The first one, the value of the y-intercept, now that's where the graph crosses the y-axis. And the value of the y-intercept would be this height. X-coordinate 0, the height is 5. The value of the graph at that point when x is 0 is 5. So the y-intercept would be 5. We've also to find the x-coordinate of this turning point. Now, if we look at a diagram of this, the thing about a quadratic graph like this, it's called a parabola, and it has symmetry. And the symmetry it's got is this axis, you can see I've drawn it in faintly there, vertical axis, and it passes through this turning point. And just to show you how that works, as a colour in the left hand side, look at the right hand side, it's mirroring what I'm doing. So the graph is symmetrical about this point T. This point here is mirrored by this point here. So the -2 and the 8, halfway between them, would have the same x-coordinate as the point T. What's the value halfway between -2 and 8? And we can do that by adding up -2 and 8 and dividing it by 2. That gives me 6/2, which is 3. And there's the mirror image of my answer. So the x-coordinate of the turning point, that's 3 in there. It'll be 3. So we have a 3 there. So here's question 6. It's a standard form calculation that we have to do. We're told to take the number 2.5 times 10 to the power 4, and that number is written in standard form. Remember, standard form numbers have a number between 1 and 10 multiplied by some power of 10. So there's a number written in standard form, and we're asked to calculate that number raised to the power -3. Now, on my calculator, what I'm going to do, there's several ways of entering this standard form number into your calculator. The way I'm going to do it just now is just as it's written. So I do 2.5 times 10, and I need to find my raised to the power button. Now you'll have one on your calculator. It may well be x to the power y. Find out on your calculator what the raised to the power button looks like. And when I press that button, up pops a little box for that index 4. So I then press 4, and that's me entered that standard form number in my calculator. And when I press equal, out pops the value of that number written as a normal number. That's 25,000. Now we have to take that number, and I press the ANS key, and that number appears, and I'm ready to do a calculation with it, raised to the power, and again I get my little index box. This time I have to put -3 in it. Now there's a problem here. You must not use the minus button when you're writing a negative sign. You use a negative button, and that's usually a minus sign in brackets. Find it out again in your calculator where that button is. So when I press that, up pops a negative, and I then press 3. So I've now got 25,000 raised to the power -3. And pressing equals now gives me the standard form answer. And it does that automatically because that answer is very, very small. Your calculator should automatically give you that number in standard form. So it's 6.4 times 10 to the negative 14. Now let's look at the other ways that we can enter standard form numbers. I'm going to press the clear button a couple of times to clear the screen. So the other way I've got of writing that standard form number is 2.5, and I'm going to use this exp button down here, and an E will appear there, and I then put my 4 index in. And when I press equals for that, there again I get the 25,000, and I would raise that to the power negative 3 as we did before to get the answer. So that's another way that I can enter that number. Now one last comment about this, let's clear that. What we could do is introduce brackets and really mimic what's written here. Write my 2.5 times 10 raised to the power of 4, and then close my brackets. Now I'm now at a stage where I can raise that because I've got brackets round it, just as I've written there. I can now press my raise to the power button again, and up pops another box, this time for the index negative 3. So press the negative button and then 3 and then equals, and I get the same answer as before. So various methods of dealing with this on your calculator. You use the method that you find easiest. So here's question 7. And here's Archie, who's flipping a biased coin 200 times. Now biased would mean that there's more chance of one side of the coin turning up than the other side of the coin. There's not an equal chance of getting heads and tails. And here's information, and he's done a series of 50 flips, ending up flipping the thing 200 times. And we have to work out the best estimate for the probability of flipping a head and giving a reason for your answer. Now, we would say that the more trials, the better the estimate. So the most trials we can include would be use the 200. And how many turned out to be heads? 52. So the estimate would be 52 200ths. Now that's not the way that we usually present probabilities. Usually as a decimal, it's a number between 0 and 1, or a fraction that's cancelled down. Now you do have calculators, so you can go 52 divided by 200, but if we half top and bottom, we get 26 over 100. So that would be 0.26, or 26 hundredths, or 13 50ths if we cancel down completely. That's a factor of 2. Now 13 is a prime number, no more cancelling is possible, but 0.26 would be a good answer for that, or 13 50ths. And the reason, the more trials, better the estimates, so use 200 trials, 200 flips. Oh, here's question 8. And we're talking here about a lion sprinting away from its den, and the graph shows the lion's distance from the den. We're asked to work out the speed of the lion in meters per second. So, It's wise to use 2 points on this graph as far away as they possibly can be. Now, I would use this point here and this point here. And reading carefully on the graph, we certainly know that the time here is no seconds. That's as it starts, hasn't run any distance. And how far away from the den was it when it started running? Well, it's one little square above 25. So we've got to decide what one little square stands for. Well, there's 5 little squares make up 25, and a fifth of 25, 25 divided by 5, will give us 5. So each little square will stand for 5 meters. 5, 10, 15, 20, 25, 30. We've got 5 meters more than the 25. So this point here is 0, 30. So it starts off 30 meters from the den at time 0. Let's see what this point tells us. It tells us the lion's been running for 5 seconds. And how far has it travelled? Well, look, that's 1 square short of this 125 metre line. So 5 metres away from 125 would be 120. So after 5 seconds, it's now 120 metres from its den. But remember, it started 30 metres away from the den. So how far has it travelled? Going from 30 metres to 120, distance travelled would take one from the other. It's 120 minus 30. Now remember, you do have your calculator, so that could be worked out if you're not sure. That's 90 metres. And how long did it take? 5 seconds. So time taken, 5 seconds. So let's just write this down. 5 seconds, it's travelled 90 metres. So in 1 second, it would have travelled a fifth of that distance. We divide 90 by 5. Do that in your calculator. You get 18 metres. So the speed, that's exactly what a speed tells you, is how far it's travelled in 1 second. That's 18 meters per second. So the answer, 18. And there's meters per second. So here we have question 9, and we're given this Venn diagram, and we're asked to shade the section represented by this expression. So let's look at what we should know about these Venn diagrams and also set notation. Well, let's just have a quick run through of things that you should know about Venn diagrams. So here we've got 2 circles. Everything inside that circle is a member of the set A. Everything inside this circle is a member of the set B. U is everything. That's the universal set. Now there are other things you should know. If we look at everything that's inside set A and then consider things that are not inside A, then we get what's called the complement of A, and that's denoted by a wee dashed here. Similarly, if we look at everything that's inside B and then we want to think about the things that don't belong to B, then we're looking at the complement of B. That's everything that doesn't belong to B. So these are two things that you should know. Another thing you should know is A union B. Everything that's in either A or B combined. That's called the union. And then the one that's relevant for this question is the things that are in A that are also in B. They're in A, they're also in B, members of A and members of B. And that's the A intersection B. So that's the one that we're after just now. And it's interesting, fun to look at other things. If we want the things that are not in A intersection B, that would be A intersection B, the complement of the whole of that. We could do a similar thing if we look at all the things that are either in A or B, and then we don't want things to be in either A or B, then we would have the complement of that set. So it's A union B, it's the complement of that. Anyway, what we're after are the things that are in A that are also in B. That's A intersection B. So we want these members of P that are also members of Q. They're in P and Q. That's P intersection Q. Well, here's question 10. And we're told that a bus route had 90,000 passengers last year, and the predictions for this year that it's going to rise by 3%, and then for next year that it's going to rise by a further 8% next year. And asking if the predicted passenger numbers for next year are more than 100,000. And emphasis is we must show our working. So an answer of yes or no is just not on. Now it's the language that's in here. Let's be very careful about what they're telling us. We've got last year, we've got this year, and then we've got next year. So let's try on this diagram and get everything that we know written down. Last year we're told there were 90,000 passengers. We're told the predictions, that increases by 3%. We're adding 3% of that to get this year's total. And then the prediction is an 8% increase. We're adding 8% of whatever this is to get next year's. That's the figure we're interested in. So first of all, let's look at adding 3% to 90,000. Now if we consider 90,000 to be the whole figure, that's 100%, and we're adding 3% to it, we're looking at 103% of this figure, the whole figure plus that 3%. And we know that percent means divide by 100. And we also know that if we divide by 100, the decimal point moves 2 places to the left, or alternatively, the digits move 2 places to the right, or 2 columns to the right. So we would end up with 1.03. And this is important because if we multiply 90,000 by 1.03, that will increase it by 3%. Then in a similar way, once we've got this figure, we would multiply it by 1.08 to increase this figure by 8% to get next year's figures. So these are the two factors that would multiply by to get the final figure. So let's bring on the calculator. So we've got 90,000 and we're multiplying it by 1.03. And that gives us 92,000 1,700. Now next year we take this figure, so I use the ANS button, this figure, and we multiply it this time by 1.08. And that gives us 100,116. So, yes, the predicted number of passengers is more than 100,000. Yes, since 100,116 is greater than 100,000. So here we have question 11. And we're told that a map has a scale of 1 to 20,000 and that two churches are 15 centimetres apart on the map. We're to find the actual distance between these churches in kilometres. So let's think about what the scale 1 to 20,000 actually means. Now the 1 would refer to the map, and the 20,000 refers to real life. So in particular, if we have 1 centimetre distance on the map, that would correspond to 20,000 centimetres in real life. We're asked to find out about 15 centimetres on the map. Now that's 15 times what we've got there. So in real life, that would be times 15 centimetres. So it just remains to change this to kilometres. Now the first step would be changing whatever this is to metres. And we know that there's 100 centimetres make up 1 metre. So we have to work out how many hundreds there are in this number, and that would give us metres. Well, we can do cancelling. 100 into 100 goes 1, and 100 into this, we just chop a couple of zeros off, and we're left with 200 times 15. That's the number of metres. Now we can go further by saying we know there is 1,000 metres, there are 1,000 metres in 1 kilometre. So we have to work out how many thousands go into this answer. And that'll give us the number of kilometres. Again, there's a bit of cancelling here. 100 goes into the 200 twice, and 100 goes into this 10 times. Now that means on top of the fraction we've got 2 15s, which is 30, and on the bottom we have 10, and 10 into 30 goes 3. So the answer is 3 kilometres. Now of course you are allowed to use your calculator, and the calculation that we would therefore do for that would be 20,000 times 15, and then the conversion from centimetres to metres, that's the divide by 100, followed by a conversion to kilometres, that's dividing by 1,000. There's 3. So it's done very easily on the calculator. So 3 kilometres for the answer. So here we have question 12. And we're given a couple of triangles. We know all the sides in this one. We know all the sides in this one. And we have to circle the reason why these triangles are congruent. Now remember, congruent triangles, we can fit one exactly on top of the other. And we're given 4 choices here, and there's letters in there. Now, what on earth do these mean? Well, let's have a look at a little animation first. So here we have a triangle. Now, I've ticked the box SSA. That means I've been given the lengths of 2 sides and an angle that's not in between the 2 sides. So these are the 2 sides I'm given, this one and this one. And there's the angle that's not in between them. And over here I've got a construction kit with exactly the same lengths. There's this length, this length, there it is there, and this angle. So I can't change the length of this, I can't change the length of this, and I can't change the size of this angle. But I can change this angle, and I can change this length. So using this construction kit, which has the same 2 sides and an angle not between these 2 sides, can I build this triangle from it? Well, let's attempt to do that. Yes, there it is. Let's check. That fits exactly on top of the other one, so it's congruent. However, there is another triangle I can build with this. Now this is the same side length, and if I stop that side there, bring this down so it's a lot shorter, this triangle has the same 2 lengths. This angle here is the same as this one, but obviously that triangle is not the same as the previous one. So if you're given a couple of triangles and you're told that a pair of corresponding sides are equal in the 2 triangles, and that an angle that's not between these sides are equal in the 2 triangles, that's not sufficient reason. SSA is not a sufficient reason to say they're congruent. The triangles could be different, as we've seen. Now let's look at another example, the AAA example. So now I have 2 triangles with identical angles. This angle corresponds to this, it's the same. This one corresponds to this, it's the same. This one corresponds to this, it's the same. And it would appear that given that information, we can only construct one triangle, and it's a congruent one to the one we originally had. However, I can make this triangle bigger. The angles are still the same. Nothing wrong with the angles, they're the same as before. But that triangle is not congruent to that triangle. So if you're given 2 triangles and you're told that each of them have the same corresponding angles, that is not sufficient reason to say they are congruent, as you can see. So the AAA condition is not any reason for saying that the triangles are congruent. So let's have a look at the example that we're given in this question, where we seem to be given all the sides. And that's 3 sides being the same. This side and this side is the same as this one's the same as this. And all I can do here is waggle these 2 sides around, because their lengths can't be altered, and I have to try and build a triangle up from the 3 lengths I'm given. And that very much looks like we can build only one triangle that fits on top of the other one to make it congruent. However, you might think there is another one that we can use, and that's down here. However, that triangle is the mirror image of the one we had, so it's actually congruent to the original triangle. So when you're given all three sides, there is only one triangle that you can build. So if you're given two triangles and you know that the corresponding sides are equal in each of the triangles, then that is sufficient reason to say they are congruent. And if we look at the triangles we're given, 12 centimetres, 12 centimetres, 17 centimetres, 17 centimetres, 9 centimetres, 9 centimetres. These are congruent triangles. The reason is SSS. We're given the three sides in each triangle. Well, here we go with question 13. And we're told that Liam takes part in the long jump competitions. And 40 jumps he makes. We're given the length of his jumps between two limits and the number of jumps he made between these two limits. And that's the total of his 40 jumps. And we're asked to estimate the mean distance of these 40 jumps. Now remember, the mean would be the total of all jumps divided by the 40. That's what the mean is. And we don't know his lengths of the individual jumps, so we have to make an estimate of that. Well, here's a larger version of the table, and they've given us a hint here asking us for the midpoint of that interval. Now, midpoint between 7.0 and 7.4 would be 7.2. Now, why are they asking us for that? Because the best we can do is to say that, look, he made 15 jumps. We don't know their precise lengths. We know they're between 7 and 7.4. Let's assume that all these 15 jumps were 7.2. Then we can go ahead trying to work out the total of all the jumps. So we're assuming all 15 of these jumps were at 7.2 metres. Similarly, for these 18 jumps, best we can do is to assume they're halfway between the two limits. That would be 7.6. So 18 jumps at 7.6. Finally, these 7 jumps were between 7.8 and 8.2. We'll assume they were all 8.0, halfway between these two limits. So 8.0. Now, if we're asked to find the total of all the jumps, what we can do is take all 15 of these, that's the number of jumps, at 7.2, add them all up. In other words, work out what 15 lots of 7.2 is. So this column would be the number of jumps times the midpoint. And that's all on our way to finding the grand total of all the jumps. So we've got 15 times 7.2. We need to bring on the calculator for this part of it. So 15 times 7.2, it's 108. Next we've got 18 times 7.6. That's 136.8. And then we've got 7 times 8. Well, that's 56, is it not? There we go, 56. And we have to find the grand total of these results. So it's 108 plus 136.8 plus 56. That comes to 300.8. So to work out the mean, estimate for the mean would be the estimate of the total of all the jumps. Well, that's a pretty good estimate. We've got 15 lots at 7.2 plus 18 lots at 7.6 plus 7 lots at 8. That comes to 308.8 for the total of all his jumps. There were 40 jumps. That's going to give us the estimate for the mean. So that answer, 300.8 divided by 40. And there we go, 7.52. So answer, 7.52 meters. So here we have question 14, and we're told that a graph passes through the points 315 and 7W. Now we're to assume in part A that the equation of the graph is a parabola, that it's a y equals x squared plus some number c. And we have to work out the value of w. That's when x is 7. We have to find out the value of w. Let's have a wee look at an animation first. Well, here we've got the graph of y equals x squared. 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. So the heights are showing the value of the x coordinate squared. 4 fours are 16 and so on. So that's y equals x squared. Now, if we add c to that, then the graph moves up parallel to the y-axis. So I'm adding values of c. Now there is only one value of c, it looks to be around 6, where the point A, that's the point 315 that we're given, lies on that curve. So one curve only will pass through the point A. If it's too much, it won't pass. If c is too little, it won't pass through. So once we've worked out the one equation, one curve, we can then go and find the point 7w. So x coordinate will be 7, and this will be way off the screen, but w will be a large positive number. So there'll be one point that has an x coordinate of 7. So we can certainly find w. So how are we going to proceed? Well, let's write down what we do know. We know that the equation of the graph is y equals x squared plus some constant c. We know that 315 lies on the graph. Now, because it lies on the graph, we know that when we put x 3 and y 15, this equation will be true. So replace y by 15, replace x by 3, that'll be true. So 15 will be 9 plus c. If we take away 9 from both sides of that equation, we'll be left with c being 6. So the equation of the graph we now know is y equals x squared plus 6. That's what we've discovered. Now, 7w lies on the graph, we're told. So again, if that point lies on the graph, its coordinates satisfy this equation. So w, that's the y coordinate, will equal the x coordinate, which is now 7 plus 6. 7 sevens are 49. When we add 6 to 49, we get 55. And as we said from the animation, w is a large positive number. So that all ties in. So let's have a look at part B now. And we're told that in fact the graph is a straight line. That's the graph that passes through 315 is a straight line. And what does this mean about the actual value of W? Can we still go through some process and find out what W is? So let's look at another animation. Well, here we have the point 315, and there's a straight line passing through it. Now that's all we're told now, that the point 315 has a straight line graph passing through it. Is this the only straight line that will pass through A? Well, no, it's not. Let's have a look at changing the gradient. The gradient at 1.5, let's make it steeper. Let's make it negative. So there's masses of straight lines that pass through that point. Now we were asked in the question to find the point on the straight line that passes through 315 that has an x-coordinate 7. Well, there it is there. However, if I now change the gradient, there's a different point. Let's change the gradient again. There's yet another point. So the value of W, that's the y-coordinate of this point, isn't determined. It could be anything. So it's impossible to tell. Well, here's question 15, and we've got a truck that's pouring concrete at the rate of 10.9 kilograms per second, and it does this for 30 minutes. We're also given a conversion factor that 1,000 kilograms is equal to 1 tonne. The question is, are more than 20 tonnes of concrete poured for these 30 minutes? And we have to tick a box showing the working. Well, let's think what this means. It's pouring 10.9 kilograms each second. So 1 second would correspond to 10.9 kilograms. Well, let's work up to this 30 minutes. Let's just try 1 minute. And we know that's 60 seconds. So in 1 minute, we'll have poured 60 times what we pour in 1 second. So it's 10.9 times 60. Now we'll not do the calculation yet. We can bring the calculator on later. So we now know, wherever this comes to, we now know that that's what's poured in 1 minute. But we want to know what's poured in 30 minutes. So that'll certainly be the amount that's poured in 1 minute times 30. It's 30 times this figure here. So that times 30. And that answer is in kilograms. Now, we didn't want the answer in kilograms. We're asked a question about 20 tonnes. We have to compare this with 20 tonnes. So we have to convert this number of kilograms, whatever it is, into tonnes. And we know that each 1,000 kilograms is 1 tonne. So we need to know how many 1,000 kilograms there are in this figure. So it's a division, isn't it? So this divided by 1,000, that'll be the number of tonnes. So let's bring on the calculator and see what that gives us. So it's 10.9 times 60 times 30, and then we have to divide that by the 1,000. And there we go. It's 19.62 tonnes. And that is less than 20 tons. So has it poured more than 20 tons? No. And there's the evidence. There's all the working that we needed. Oh, here we have question 16. And we're given some information about the lengths of leaves. Someone's been out measuring the lengths of leaves and got a whole lot of measurements. And we're told information about shortest, longest, upper quartile, median, interquartile range. We're asked to draw a box plot to show this information. Well, let's first of all talk about what a box plot is. Here's a box plot. Now, if you've got a whole lot of measurements and you put them in order, the smallest up to the largest, and you pick the middle one, that's the median. Then you look at the bottom half of the measurements and you choose the middle one of these, then you're looking at the lower quartile. Then if you look at the top half of the measurements you've got and you choose the middle one of them, you're looking at the upper quartile. So you can see that the box on here tells you the lower quartile, the median and the upper quartile. And the length of that box, that's the difference between the lower quartile and the upper quartile, is called the interquartile range. So the length of the box shows you the interquartile range. And then there's always, in a bunch of measurements, when you put them in order, there's always a largest value and there's always a smallest value or a least value. So that's basically what a box plot shows you. So let's have a look at a larger diagram of the one that we're trying to draw, and we'll have a look at what we're told. The shortest length is 2.4. 5 boxes between 2 and 3, each one must be 0.2. Well, 2.2, 0.4, 0.6, 0.8, 3. So 2.4 for the shortest length. Now I'm just going to put little marks down just to try and get these 1, 2, 3, 4, 5 points, 5 statistics that were possibly given here, and get these 5 on a number line here, and then we'll be able to draw the box plot once we know them. So certainly the shortest line is 2.4, longest length, no problem, that's on the 9 line there. Upper quartile, 7. That's the top end of that box. The median length is 6. That's the line shown inside the box for the median. Now, we don't know the lower quartile, but we do know the interquartile range, and that's the length of the box. So the upper quartile is at 7. The interquartile range is 3. The length of the box is 3. So let's count along. 1, 2, 3. There's the lower end of the box, so that must be the lower quartile at 4. So let's put the box in. So there's the box, and we'll complete that median of 6, straight line there. Now what's left? Well, we join up with a line along to the largest value. We should maybe increase that line a bit just to make it clear where the largest value is. And similarly, a line down to the least value and maybe make that a bit more distinct. There we go. So there is the box plot that we were asked to show. So here's question 17. We're told that AB is a straight line, and here's a dividing line drawn here to separate a couple of angles. So these two angles, because they form an angle, a straight angle, must add up to 180 degrees. Now we're asked, once we've worked out the value of x, to work out the ratio of the smaller angle to the larger angle. You can see the smaller angle is this quarter x plus 15. Anyway, the main fact is that 1/4 x plus 15, that smaller angle, if we add it to the larger angle, that's 2/3 x minus 44, then we get 180. Now first of all, we're in an equation, so I'm going to work out these constant numbers. I'll leave the quarter x and the 2/3 x added just now, but I'm going to take 15 away from both sides, so that'll disappear, and I'll have to take 15 away from the right hand side. I'm going to add 44 to both sides, that'll get rid of this, and it'll appear as a plus 44 over here. Now remember, we do have calculators which you're able to use to do these calculations. So let's bring the calculator on, and we've got 180 minus 15 plus 44. That comes to 209. Now I'm looking at these fractions. Next step is to get rid of these fractions. And what I'll do is take the left hand side and multiply everything by 12. Now the reason I'm doing that is because 4 and 3 both go into that 12, so that would simplify these. So take both sides and multiply them by 12. Okay, so 12 times 1/4 x. Quarter of 12, 4 into 12 goes 3. So that'll give me 3x. And then 2/3 of 12, well, 3 into 3, 1, 3 into 12 goes 4, 2 4s are 8. Or you could do that on your calculator. So that gives us 8x, and we've got 209 times 12. So 209 times 12. So that's 2508. And 3x plus 8x gives us 11x. So final move, we'll do the opposite of multiplying by 11. We'll divide both sides by 11. And let's see what that gets us. Well, on the left hand side we just have an x, but 2508 divided by 11 gives us 228. So x equals 228. Now that would allow us now to find this smaller angle. That's 1/4 x plus 15 will give us 1/4 of 228 plus 15. So we take that answer and divide it by 4. That's 1/4 of 228, then add 15. So we get the smallest of the two angles being 72. Then the larger of the two angles is 2/3 x minus 44. So that's 2/3 of 228 minus 44. So we take 2 divided by 3 times 228 and then subtract 44. 108 for that one. So required ratio, smallest angle 72, largest angle 108. So it's 72 to 108. Now 9 goes into both of these. 9 eighths are 72, and 9 into this goes 12. And 4 goes into each of these. So we can simplify it to 2 to 3, but that would give you full marks. Well, here's question 18, and we're told the diagonal of a rectangle is 23.7 centimetres long, and that diagonal makes an angle of 52 degrees with one of the sides of the rectangle, a side that's got length x centimetres. We're asked to work out the value of x. So we can't do much without seeing this rectangle and figuring it out from the diagram. So there's a nice healthy rectangle. Let's draw in a diagonal and let's see what we can do from there. So the diagonal has length 23.7 centimetres. And it makes an angle of 52 degrees. Well, let's choose this angle because this one looks less than 45. This is more than 45. So let's say this is the 52 degree angle. And it makes 52 degrees with one of the sides of the rectangle. That'll be this one up here. So let's call that x centimetres. And remember, rectangles have right angles. So we're basically looking at a right angled triangle where we know the hypotenuse, and if we're sitting at 52 degrees, we also are interested in the adjacent, that's the side right next to you that is not the hypotenuse. This side up here is the opposite. We're not concerned with that. So obviously trig is coming into this, and we're wanting to know what uses the adjacent and the hypotenuse. Now, in your formula sheet, you've got a little diagram with A, B's and C's showing you the sine, cosines and tangents. I prefer working with SO, CA, TOA. And which of these three parts involves an A and an H? Well, it's this bit in the middle. And that tells us that the cosine of the angle is the adjacent over the hypotenuse. So let's write that down. The cosine of this angle, 52 degrees, is equal to the adjacent over the hypotenuse. So there's the adjacent, that's x. There's the hypotenuse, 23.7. So I'm now looking at an equation. I'm trying to get x on its own. Let's get rid of this divide by 23.7. What's the opposite of dividing by 23.7? Multiplying by 23.7. That will get rid of that divide by 23.7, leaving you with x on the right hand side. But in an equation, keeping it balanced, we do the same to both sides. So on the left-hand side, we've got 23.7 times the cosine of 52 degrees. On the right-hand side, we've just got x on its own. So there's the recipe for finding the value of x. We take 23.7 and multiply it by the cosine of 52. Now, before you launch into this on your calculator, make sure that your calculator is showing degrees, not rad not grad. It's showing degree. You should know how to find which mode your calculator is in. It's like different languages. It has to be speaking degrees or you'll get the wrong answer when you put these values in. So let's do the calculation. 23.7 times the cosine of 52. And we know it's in degrees. So there is the value we get. So x is 14.591, etc. X is 14.591, etc. So I think we should round that off probably to 3 significant figures. Chopping a 9 off that 5 will go up to a 6. So it's approximately 14.6 centimetres. And that's to 1 decimal place or to 3 significant figures. So here's question 19, and in part A we have to show that this algebraic expression simplifies to an integer. So let's see exactly what we're doing here. We've got 4x multiplying 3x plus 2. Then we've got a negative 2x squared multiplying 6 minus 5 over x. And then we've got a negative 6x multiplying 3 plus 7 over x. So there's 3 terms, and each term is a product. Now, first of all, let's do this 4x. And we're multiplying both the 3x and the 2 by that 4x. So 4x times 3x, 4 times 3 is 12. X times x is x squared. 4x times 2, 2 lots of 4x, 8x. Now, seconds away, let's do round 2. So we've got this negative 2x squared multiplying the 6 and then multiplying a negative 5 over x. So let's tackle the first one. Negative 2x squared times positive 6. Negative times positive is negative. 2 6's are 12, and we've got our x squared. Now the next one deserves a little bit on its own over here. Negative 2x squared times negative 5 over x. So the first thing to notice is it's 2 negatives we're multiplying together. So they vanish because you're getting a positive. So we're getting 2x squared times 5 over x. That's a positive answer. And what on earth does 2x squared times 5 over x mean? Well, on the top of a fraction we've got a 2 times an x times an x, that's 2x squared, times a 5, and then on the bottom of the fraction we've got an x. Now we can cancel between the top numbers and bottom numbers. X into x goes 1, x into x goes 1. And what we're left with? We're left with 2 times x times 5, that's 10x over 1, that's just 10x. So that comes to 10x. And finally, let's do the negative 6 times the 3, and then negative 6 times the 7 over x. So negative 6x times positive 3, negative times positive is negative. 6 times 3 is 18 with an x. 3 lots of 6x, 18x. The next one deserves its own little bit of working out. Negative 6x times positive 7 over x. Now, negative times positive, the answer is going to be negative. And let's think of this as a fraction. There's a 6 times an x times a 7 on the top, and there's an x on the bottom. And again, there's cancelling, top and bottom. X into x goes 1, x into x goes 1. And we've got 6 7s, 42. So it's negative 42 over 1, which is just negative 42. So far so good. Now, what have we got? We've got 12x squared minus 12x squared. That cancels. We've got 8x plus 10x. That's 18x. And look, there's a minus 18x, so the x's cancel. Now, not a lot left. We're just left with this negative 42. And that is an integer. And you remember, an integer is a positive or negative whole number, or 0. So there we go. We've shown that that expression, when it's simplified, is an integer. So let's have a look at part B. And we're asked to factorise the expression 8x squared minus 18x minus 35. Now I'm going to look at the FOIL. I'm going to use the FOIL method, which involves thinking about pairs of brackets in the following way, where we can multiply the firsts. That's the first term in each bracket. O is the outside 2 multiplied together. I is the inside 2 multiplied. And then L stands for the last 2 multiplied together. Now, in the case of trying to factorise this, there's an awful lot of possibilities. Let's have a look at some of them. For the firsts, we have to get an 8x squared. Now, that could be an 8x and an x. Or there's another possibility for the product of the first 2 terms, giving you 8x squared. It could be a 4x times a 2x. 4x times 2x does give us 8x squared. And then look at this 35. Now, it could be 35 times 1, but that's a very large number, 35. Now let's try 5 7s. Now remember, if this doesn't work, we can go back and try 35 times 1. But 5 7s are 35. And because the 8x and the x are different, I'm going to swap the 5 and the 7 round. That'll give us a different answer. And the same with the 4x and the 2x. We could have a 5 times a 7, or we could swap them round. So there's all sorts of possibilities for factorising this expression. And remember, I haven't tried the 35 times 1 and swapped that round yet. Now, how do we tell these apart? Well, the crucial bit is in the middle 2 terms. In this first example, let's look at that. 8x times 7 are the outside 2, 7 8s are 56. That would give us a 56x. And the inside 2, 5 times x, would give us a 5x. Now, remember, it's these 2 that are going to combine to give us this negative 18x. Now, adding and subtracting, there's no way we can get an 18 from a 56 and a 5. So this one's not very promising. Let's try this one. The outside 2, 5 times 8x gives us 40x. And the inside 2, 7 times x gives us 7x. Now, adding and subtracting these, we're still not going to get a negative 18x from these 2. Okay, that's not successful. Let's try this third example. The outside 2 gives us 4x times 7. that's 28x. The inside 2 gives us 5 times 2x, that's 10x. Now things are looking up here because I can get a negative 18x from these two. Now think what I'd have to do if I went to negative 28 and then added 10. I would be at negative 18. Think of the number line. If you're at negative 28 and you add 10, you're going to be at negative 18. So it's a minus 28x and a positive 10x. So we go back to this and we say, okay, it's positive 10x. There's the 10x. Positive 5 times the positive 2x. Negative 28x. That's the negative 7 times this 4x. And that gives us negative 28x. And you just check that the last terms, positive 5 times the negative 7, gives you the negative 35, which, yes, that's what we were after. So the answer to factorising this is 4x plus 5 times 2x minus 7. Now, if you've been taught, let's take the 8x7 and the x5, if you've been taught a table method to multiply out brackets, then you can do the same figuring out that I've been doing with your table. There's your 8x squared, that's the first two terms. The last two terms, 5 7's 35. We don't bother about positives and negatives just now. 7x goes in there and 40x goes in there, and there's your inside and outside terms, these two diagonal ones, the 40x and the 7x, and it's clear from this that you cannot get the negative 18x. So you'd move on to maybe this next one where it's 4x and 5 and 2x and 7, and make up your table from that with your 8x squared there, your 35 there, and here's your 10x, and there's your 28x, and you're saying, oh gosh, that if that was negative 28x and that was positive 10x, we can certainly get our negative 18x. How do I make this negative? I put negative there. Negative 7 times 4x is negative 28x, and that's negative, so negative 7 times 5 gives us a negative 35 there, and everything's hunky-dory, and that gives us the 4x plus 5, that's positive, we haven't altered that with a negative, times 2x minus 7. So here we have question 20. And we're given this equation, and we're also given this statement about x with letters D, E and F, and that's what we're trying to find, a possible set of values for D, E and F. So let's see what we can make of the equation first of all. So we've got x minus 9 on the left hand side, and we've got a fraction. The numerator, top of the fraction, two lots of 6 minus x squared, and on the denominator, bottom of the fraction, we've got x plus 3. So I think the first move would be to get rid of that fraction, and we can do that by doing the opposite of dividing by x plus 3. We'll multiply both sides by x plus 3. So the whole of the left hand side will multiply, that's the x minus 9. We'll multiply that by x plus 3, and when I multiply the right hand side by x plus 3, that denominator just becomes 1. So we've got 2 lots of 6 minus x squared. Now next step would be to multiply out the brackets here. You might have been taught to put it in a table, but whatever way you do it, first terms give us x squared, the outside two give us negative 9x, the inside two terms give us plus 3x, and the last term in each bracket, when we multiply them, gives us minus 27. And also multiplying out the right hand side, 2 lots of 6, 12, 2 lots of negative x squared be negative 2x squared. Now this is a quadratic equation, x squared terms, x terms and constants. And the way we solve quadratic equations, remember, is to get everything on the left equals 0. And we'll do that by getting rid of this 12. And we'll have to do that to both sides to balance it. And let's add 2x squared to both sides. And that'll get rid of the negative 2x squared. So that's what we do to both sides. So we've got x squared plus 2x squared is 3x squared. Negative 9x plus 3x will be negative 6x. Negative 27 minus 12, that's like negative 27 and another negative 12, that'd be negative 39. That disappears, 12 minus 12, and negative 2x squared plus 2x squared, that disappears also. So we've now got it in the normal quadratic equation form. But notice on the left hand side, there's a factor of 3 in each of these 3 terms. I'm going to divide both sides now by 3. So everything on the left hand side gets divided by 3. 3 into 39 goes 13. And dividing 0 by 3 just gives us 0. So they're smaller numbers, more manageable numbers. Now on your formula sheet, you do have the quadratic formula given to you. And you're told that the solution of ax squared plus bx plus c equals 0 is this expression. So let's compare what we've got with ax squared plus bx plus c equals 0. And of course that's a 1x squared that we've got there. So if we're comparing the coefficients of x squared, a is equal to 1. If we then compare the coefficients of x, b is negative 2. And then comparing the constant at the end, c will be negative 13. So we've got our values of a, b and c. Now we know that the solution to ax squared plus bx plus c equals 0 is given by this quadratic formula. So that's x equals negative b. Well, that's the negative of negative 2. Plus or minus, there's always a choice. And it's the square root of b squared, that's negative 2 squared, minus 4 times a times c. 4 times a is 1, c is negative 13. And that whole thing gets divided by twice a. Well, let's see what that comes to. The negative of negative 2 is 2, plus or minus. Now let's do a little bit of working at the side here. Negative 2 squared minus 4 times 1 times negative 13. So negative 2 times negative 2 is positive 4. For this second term, negative times a negative will be positive. And 4 times 1 times the 13 is 52. And 4 plus 52 is 56. So that's 2 plus or minus the square root of 56 all over 2 times 1, which is 2. Now let's compare what we've got here with the expression that they've asked us to find, and it's d plus or minus the square root of e over f. So we just need to read off the corresponding values. You can see that d is 2, e is E is not root 56, E is the number under the square root sign. So E is 56 and F is 2. So let's write that down. D is 2, E is 56 and F is 2. Now that is one possible set of values. Remember at this stage where I cancelled the factor of 3 in each term. If I'd gone ahead and done this calculation with A being 3, B being -6 and C being -39, I would have got a different set of values for D, E and F. That's why they put down one set of possible values for D, E and F. There are other sets of values that would have done. So here we are, question 21, and it's a problem about the number of people in a stadium. They're distributed between the north, east, south and west stands, and we're told different pieces of information about the numbers in each stand. And we're asked to find ultimately how many people in total are in the stadium. So here's the pitch. And let's look at the north stand, it'll be up there. The west stand, over here. The east stand. And finally, the south stand. And let's just look at what we're given. We're given that in the north stand, a quarter of the total in the stadium are in there, and in the east stand 3/10 of the total in the stadium are in there. We're also given another piece of information, and that's to do with the ratio of the people in the south stand to the people in the west stand, and that's 2 to 7, or 2 parts to 7 parts. So 2 parts down here, 7 parts up here. 2 parts to 7 parts. And then the final piece of information that we're given is the total number of people in the west stand is 4,480. So how are we going to work this out? Well, looking at this information, 7 parts, 4,480. 7 parts correspond to 4,480 people. So what would that make 1 part? Well, it would be a 1/7 of this. We divide that number by 7. But there's 2 parts in the south stand. So how would we get 2 parts knowing the size of 1 part? Well, we'll just double it. So whatever number this is, we'll double it. So that's 4,480 divided by 7 multiplied by 2. 1,280. Now let me add that information to my diagram. So that's 1280. So that's us taking care of the 2:7 ratio. Let's deal with the fractions up here. And if we add a quarter to the 3/10, we'll find the fraction of the total people that are in the north and the east stands. That would presumably help us. So let's try that. There's 1/4 plus 3/10. Now denominators are different. Number 20 comes to mind. 4 goes into 20 and 10 goes into 20. So let's change both of these fractions into 20ths. So we'd be multiplying 4 by 5. So we'd have to multiply this 1 by 5. So it's 5/20ths for that quarter. We'll need to multiply this 10 by 2. So we'll have to multiply this 3 by 2. So 3/10, same as 6/20ths. So how many 20ths do we have? 5 of them plus another 6 of them. Well, that's 11/20ths. So we know that 11/20ths are in the north and east stands. Well, what fraction are in the south and the west stands? Well, that's the rest of them. If we've got 11/20ths, the rest of them, that's 9/20ths, are in the west and south stands. 11/20ths plus another 9/20ths would be 20/20ths. That's the whole lot of people that are in the stadium. So 9/20ths are in the west and the south stands. So how many are there in the west and the south stands? Well, there's 4,480 plus 1,280. That's easily done on your calculator. That'll give you 5,760. So 9/20ths corresponds to 5,760. Well, what'll 1/20th be? If we've got 9 of them correspond to this, 1 of them will correspond to 1/9 of that. We'll have to divide that by 9. But what are we after? We're after the whole lot. That's 20/20ths. So if we know 1 of them is this, then 20/20ths will be 20 times this. So it's whatever that number is times 20. So we've got 5760. We're dividing it by 9, and then we're multiplying it by 20. This should be our final answer then. We've got 12,800. And that's the total number in the stadium. Well, here's question 22. And in the box here, we're given an iteration formula, and we're told that it starts at 1. And we have to use this formula to work out an approximate solution to this equation, x equals 5 minus 1 over x. And we have to work to 4 significant figures. So let's figure out what this iteration formula is telling us. We start out with x1. To get x2, (5 minus 1 over x1, n is 1, will give us x subscript 1 plus 1. That's x2. So we've to perform 5, the calculation 5 minus 1 over x1 to get x2. And similarly, to get the next term of the sequence, x3, and we put in here x2. 5 minus 1 over x2, n is 2, will give us x2 plus 1, 3x3. So again, it's the same calculation, but this time using x2 to get to x3. And this series of calculations will give us our iterations, which should, in theory, get closer and closer to the required value that we're after. So we'd know we start with a 1. The calculation we make is 5 minus 1 over 1. Well, that's 5 minus 1, which is 4. And we continue. The calculation we do now is 5 minus 1 over 4. 5 minus a quarter, that's 4 3/4, 4.75. The next calculation would be 5 minus 1 over 4.75. And we're getting rapidly to a stage where the calculators needed to do this. So we're going to produce a sequence of values, and hopefully they're going to get closer and closer to the solution of x equals 5 minus 1 over x. And because we've to work to 4 significant figures, we don't need to write too many digits down, so long as we've got more than 4 significant figures and we can see what is happening and how close they're getting to a final value, then we should be okay. So let's bring on the calculator and see what we can do with these calculations. So we start off with 1. Now I will show you a quicker method of doing this on the calculator. Most calculators will manage a quicker method, but to demonstrate this, I'll do each individual calculation. So we start with 1, we then do 5 minus 1 divided by that answer, which was 1. That we know gives us 4. So we start with 1, we're now on to 4. Our next calculation again is 5 minus 1 divided by that answer, and as we suspected, that's 4.75. Next up, 5 minus 1 divided by 4.75, and that'll give us x4. So that's 4.78947. 4.78947. Now, 4 significant figures, 1, 2, 3, 4. I'll just keep a couple beyond that, so I'll work just now to 5 decimal places. But we know these figures now, these decimals now go on and on and on. So let's do the next one. So that's 5 minus 1 divided by that previous answer. And there we go, it's 4.79120. Now you can see these are beginning to agree with each other, possibly up to 2 if we rounded these off to 2 decimal places. That's really 3 significant figures so far. Let's look at the next calculation. 5 minus 1 divided by that previous answer. And we've now reached 4.79128. And since I'm only working to 4 significant figures, you can see that this rounded to 4 significant figures is exactly the same as this rounded to 4 significant figures. So we've finally got our value for x, 4.79128. 1, and that's to 4 significant figures. And we needn't go any further because all the subsequent numbers will be rounded to 4.791 if we're only concerned with 4 significant figures. So that sequence goes on and on. However, there is a faster way. I mentioned that the calculator does this, and let's just check up how that works. Let's clear this. And what we do is we start off the same way as we started. We load in a 1, and we then put in this formula. Now, how do we do that? Well, we use the right-hand side. We go 5 minus 1 divided by ans. Now, that's what we did for producing the 4, the x2. But in this case, I'm just going to press the equals again for x3, and again for x4, and again for x5, and so on. I just need to keep pressing the equal sign, and it performs 5 minus 1 over the previous answer. So I've now reached that. Now I can easily now just keep calculating, and you know, see at this stage nothing changes. So this figure is accurate to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 significant figures. Far more accurate than we required. But it is essential in this question that you list the intermediate values to show that you've produced these values and that you know what you're doing when you round it off to 4 significant figures. Oh, here we have question 23, and we're given this diagram where various lines are represented by these vector expressions, and we've to prove that DEF is a straight line. Now I think what we should do is look at the journey from D to E and the journey from E to F, and if it's possible to write the journey from D to E in terms of the journey from E to F, then we should be closer to working out whether DEF is a straight line or not. So the first thing to do is to look at the journey from D to E. So we're travelling from D to E. We'll not go the direct route though. We'll involve these lines. So we're going from D to C and up from C to E. So not the direct route, we'll go the scenic route. So we go from D to C, followed by C to E. Now in terms of these vectors, what does this represent? Well, DC represents 6A plus B. And what does CE represent? It represents 2A minus 5B. And we can add these like we do algebra letters. 6A plus 2A, 8 lots of A. And 1B minus 5B would be negative 4B. So we've got the journey from D to E representing 8A minus 4B. 8A minus 4B. Well, let's do a similar exercise for E to F. And again, let's not go the direct route. Let's go the scenic route via C. So E ouch to C. Now that ouch came about because of hitting this arrow. We're right into the arrow. The arrow's pointing at us. So that's a significant thing for us. We'll have a look at what that means in a second. So E ouch to C followed by C to F. So E to to C followed by C to F. And what does E to C represent? Well, that ouch came from hurting ourselves hitting that arrow. And that's significant. What it means is that we have to do the negative of this. After all, it's the journey from C following the arrow up to E that is representing 2a minus 5b. So if we do it in the opposite direction, it'll be the negative of that. So that represents not 2a minus 5b, but the negative of 2a minus 5b. And then C to F, that goes with the arrow, so that's no problem. It's 4a minus 6b. So a little bit of simplifying here. It's like we've got a negative 1 outside the bracket, so negative 1 times 2a gives us negative 2a, and negative 1 times negative 5b will be positive 5b. So again, that negative 2a plus 5b is the opposite of this because we went against the arrow. And then we've got a 4a minus a 6b. So let's simplify that. 4a minus 2a is 2a. 5b minus 6b is negative b. Now we can immediately see that this journey represents a vector that is 4 times this vector. Let's write that as 4 lots of 2a minus b. So if this E to F represents 2a minus b, then you can see that the journey from D to E is 4 times the journey from E to F. We can write one in terms of the other. Travelling from D to E, we're doing 4 times what we do travelling from E to F. Now there's various things that means. It means that DE and EF are parallel. Now does that mean they're in a straight line? Not quite, because we could have 2 lines parallel that are not in a straight line. But the point here is that E is shared, so this situation cannot arise. So E is a common point. And all these facts mean that DEF is a straight line. So there's our proof. Well, here's question 24. And we're told that a room is kept at a constant temperature of 21 degrees for 6 hours. Now there's the time in hours, so from 0 up to 6 hours after we started, there's the temperature constantly 21 degrees. Then the heating's turned off, and of course the room begins to cool. So the temperature is going down now, and there's a sketch showing that. Well, we've just been over that. Now, assuming in part A, assuming the equation of this curved part, that's this bit here, is y equals k over x, where k is a constant, work out the value of y when x equals 12. So let's write this equation down. Y equals k over x. And what do we know about this curve? Well, we know that this point lies on the curve. So that's got an x value of 6 and a y value of 21. So we know that when x equals 6, y equals 21. So 21 will be k over 6. Multiply both sides by 6 and we'll get 21 times 6 being equal to k. Now 21 times 6 is 126. So the equation is y equals 126 over x, we now know. It says work out the value of y when x equals 12. So when x equals 12, y will be equal to 126 over 12. Now you do that on your calculator and you'll get 10.5. Let's look at part B now. And we're told that in fact the equation of the curve is a bit more complicated than k over x. Y is some constant times a third to the power of 6th of x. And it says, how does this affect the value of y when x equals 12? So we'll need to go through the same type of process that we went through in part A. So let's write down the equation of this curve. So it's 1/3 that's being raised to the power of 1/6 of x. And again, we'll do what we said before, or we'll do what we did before. When x equals 6, we know that y is 21. So let's plug these values in. 21, therefore, will be a times 1/3 to the power of 6th of x. That's a 6th times 6. So 21 is a times 1/3 to the power, now what's a 6th of 6? 6 into 6 just goes 1. So we're talking about a times 1/3. Anything to the power 1 is just the same number. So that's 1/3 of a. 21 is 1/3 of a, so a will be 3 times 21. So that's 63. So as before, once we've worked out the constant, we know what the equation is. So the equation of that curve is y equals 63 times 1/3 raised to the power of 6th of x. And we were interested in x being 12. That's what we're interested in. And we'll have to compare the value of y in this new scenario with the old value that we got. So let's do the same as we did before. When x equals 12, y will be 63 times 1/3 raised to the power 1/6 of 12. So it's 63 times 1/3 raised to the power, well, 1/6 of 12, 6 into 12 goes 2. So we're doing 1/3 times 1/3. And 1/3 times 1/3 will be 1/9. So it's 63 times a ninth of 63. That's 7. 7 nines are 63. So how does that compare with the previous value? Well, it's less. This is less than 10.5, which is what we got before. So the value of y is less than the answer to part A. Oh, here's question 25. And we're shown a diagram of a right-angled triangular prism with the lengths shown as A, B, C and D. And we're told the ratio of these edges, A to B to C to D, is 3 to 4 to 5 to 12. We're actually told the volume of the prism, it's 1,125 cubic centimetres. And we have to work out the total length of all the edges of the prism. So let's look at a larger diagram. Now, it's not true that we can say this is 3, this is 4, this is 5, and this is 12. If we said that, that wouldn't be the only possibility. Suppose we doubled all these lengths and had 6, this was 8, this was 10, and this was 24. That would still give you the same ratio. You could multiply them all by 3, by 4, and by 2.5, and so on. So what we can say is that we can say that A is 3 times something. If it was 1, then this would be 3. But it could be 2, in which case this was 6, and so on. And if A is 3k, then B would be 4k to keep the ratio correct. And of course C would be 5k and D would be 12k. So if we replaced k by 1, we'd get a 3, 4, 5 and a 12. But we could double that size by replacing k by 2, get 6, 8, 10 and 24 and so on. So value of k could be anything you like. That'll keep these ratios correct. So that's all that we can say about these sides. Now we do know the volume, and what we can say is that the volume of that, suppose there was a complete cuboid. You can see how a complete cuboid would look. And the volume of that prism would be exactly half the volume of that cuboid. So the volume of the prism would be a half the volume of the cuboid. That would be a half of, now we know volumes of cuboids, length times breadth times height, A times B times D. You just multiply the 3 dimensions together. And in this case, we're saying that A, all we know about it is it's 3 times something. B is 4 times something. And D is 12 times something. So let's figure that out. We've got a half times 3 times 4 times 12. Well, that'll be 72. You can figure that out in your calculator. K times K times K, K cubed. So that's the volume, but we're told the volume is 1125. So that should be sufficient for us to work out what K is, because that would mean therefore that K cubed is equal to 1125, and we'll divide both sides of that by 72. So we can now finally say that K would be the cube root of 1125 divided by 72. Well, let's get the calculator onto that one. So it's 1125 divided by 72. And I want the cube root of that. Now, on my calculator, there's raised to the power. This is cube root, fourth root, and so on. So I would first of all tell it I'm finding a cube root, use my shift to get access to this on this button. It comes up with that. I'm wanting the last answer. Find a cube root of 15.625. Now you'll need to find out in your calculator how you can get cube roots. that equals 2.5. So I now know that k is 2.5. So I can work out the values of A, B, C and D. So A is 3 times 2.5, that'll be 7.5. B is 4 times 2.5, that's 10. C is equal to 5 times this, that's 12.5. And D is 12 times this, that's 30. So finally, the total length of the edges, well, let's have a look at this. How many A's are there? There's this one and the one at the other end. So there's 2 of them. And how many lengths B are there? There's this one, and there's the length at the other end. And how many lengths C are there? There's this diagonal one and the diagonal one at the other end. So there's 2 of them. And finally, how many lengths D's are there? Well, there's this one, and then there's 2 at the fat end of the wedge. So there's 3 lots of D. So that's the calculation we have to make. Twice A, that's 15. Twice B, that's 20. Twice C, that's 25. And 3 times D, that's 90. And when we add all of these up, we get 110, 135, 140, 150. Now, of course, your calculator should be used for that, just to reinforce that you've got the right answer. So it's 150 centimetres for the total length of the edges in that triangular prism. So that's Mr. Corsi signing out, and I hope you enjoyed the video.